final piece of this unit that we want to make sure we cover is how to solve a rational equation. So we're solving rational equations. For this first example here, we want to look at something that looks like x squared minus 2x minus 3 and x plus 1 equals 17. So as always, just same thing with when we were graphing, we want to factor this if possible. So we factor this numerator here. We've got x minus 3x plus 1. We get x plus 1 on the bottom equals 17. We can actually cancel the x plus 1s in this case, and we're just left with x minus 3 equals 17. Add 3 over, and we get x is 20. So that was a pretty simple rational equation. That does happen from time to time, where you can just factor, cancel, and have a nice linear equation. But for the most part, that's not usually the case. That's not usually what you're going to see happen. So we do see some problems where you're going to need to know how to cross multiply. And so we'll look at one of those. We've got one like 2 equals x plus 2 over x minus 3. And so in this case, there's nothing that we can factor and cancel, but we have created our own proportion. So if we're going to cross multiply, we have 2 times x minus 3 equal to x plus 2. We'll distribute that 2 to get 2x minus 6 equal to x plus 2. And when we do that, we're going to get all the x's to one side, so I'll subtract this x over and add my 6, so I get x minus 6 equals 2. Add my 6 over, I get x equals 8. So not so bad, pretty simple when you cross multiply. This kind of example for rational functions that you might see, if you cancel it, turn it into a linear equation, cross multiply, is when you have to find a common denominator. So this first one here, n minus 3 over n squared plus 5n plus 1 over n equals 1 over n plus 5. All right, so thinking back to our partial fraction decomposition unit or section, we want to find a common denominator. So here this actually factors into n plus 5. So that is exactly what we want to do. So we're going to have to multiply this top and bottom by n plus 5 to give that a common denominator, and this side by n and n to give that a common denominator. When we do that, we can then just solve the numerator, whatever that is. So in this case, it's n minus 3 plus n plus 5 equal to n. So we combine like terms. N plus n is 2n. Negative 3 plus 5 is 2 equals n. Subtract this n over. Do I want to do that? Yeah, I do. Subtract the n over, give me a positive n. And subtract the 2 over. So I get n is equal to negative 2. Is this canceled? This canceled. Moved it over there. N is negative 2. So not too bad. Now I do want to check that, make sure that negative 2 is a solution. If I plug this in here, nothing makes the denominator 0, so it is still a solution. For our next example, we have 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. So for starters, we always want to find that least common denominator. If we factor here, we get x minus 3x minus 1, which happens to be the other two pieces of our denominator, which is great. So the only thing we're missing here is an x minus 3. Here we're missing an x minus 1. And we have what we need in the far right one there. So if we distribute 2x times x, we get 2x squared. 2x times negative 3 is 6x. Then we're going to add x minus 1 and set that equal to 2. So now we want to solve this. Combine like terms, so we have a 2x squared. And we're going to combine negative 6x and x to give us minus 5x. And then we'll subtract this 2 over, so minus 3. And so then we go to solve this. We do need to solve this using x method. So we're going to find 2 factors of negative 6x squared that n give us negative 5x. Not too bad. Negative 6 and positive 1. So negative 6x and 1x. And we'll put that in for 5x. So remember that substitution happens here. This is not one of the problems that we can solve using our quick method here. We have to substitute those in. So we have 2x squared minus 6x plus x minus 3. And we'll solve this by grouping. So we'll group the first two and the last two. Take out a 2x, we're left with x minus 3 plus 1, x minus 3. Remember that placeholder of 1 is important. You need that to be able to finish your problem. 2x plus 1 and x minus 3. So when we solve both of those, remember these are equal to 0. The 0 carries along, all along. And so we end up with negative 1/2 and x equals 3. So x equals negative 1/2 and 3. But we do need to check both solutions to see if they both work in the denominator of our problem. So negative 1/2, no problem. Negative 1/2 minus 1 is negative 1.5. Negative 1/2 minus 3 is negative 3.5. And if we plug these in, those work as well. So, but when we plug 3 in, 3 minus 3 is 0. We cannot have 0 as the denominator of a fraction, because we know the world ends then, so we don't want that to happen. So in this case, 3 is not a solution. Only x equals negative 1/2 is the solution that we want for this problem. So make sure you're checking for those extraneous solutions. We can't have anything that makes the denominator 0. So for our next example, take a look at another one. This one I want you to do on your own here. So we've got x minus 3 over x plus 3 over x plus 2 plus 6 over x squared plus 2x equal to 0. So yeah, we have 3 portions of this fraction. That's okay, nothing wrong with that. And you're going to have to find the common denominator for all of these. So go ahead and do that. In this case, you're missing the x plus 2. In this case, you're missing the x. In this case, you're missing nothing. And anything times 0 is still 0. So we have x squared minus x minus 6 plus 3x plus 6 equals 0. Combining like terms here, we get x squared plus 2x, and that goes away, equal to 0. So we factor this out, x plus 2. So we get x is equal to 0, and x is equal to negative 2. When we plug these in, 0 cannot be in the denominator here. Negative 2 cannot be in the denominator here. So what happens here is that neither one of these solutions is possible. So there's actually no solution. That is okay. That's a thing. No solution. So there's actually no solution to this equation.